In this problem session, I'm going to talk about syllogisms and the STAR test for determining validity. Before proceeding with this video, it would be a good idea to make sure that you have a good handle on syllogistic translations first, because I'm just going to be assuming symbolisms going forward in this video. I'll start with a review of the definition of a syllogism, which you've probably already read in the textbook. If you haven't, I would recommend going back to do that first, because this is going to be a quick recap, so it's fresh on your minds. So a syllogism, the technical definition of it, is a vertical sequence in which each line is going to be at least one, but possibly more, is a woof, or a well-formed formula. Each letter has to occur exactly twice. So, for example, if there is a Y in the syllogism, then there's going to have to be exactly two of them, not one, not three, exactly two, in order for it to be a syllogism. Moreover, the letters have to form a chain. And what that means is that every two consecutive lines have to share at least one letter. So the first and second lines will have to share at least one letter. The second and third lines will have to share at least one letter, and so on. But moreover, the very top and the very bottom lines have to share a letter with each other. Now, if you don't have more than one line, if it's just one line, which is possible, then you can ignore the rule about forming a chain. It can still satisfy the criteria for syllogism if it meets the first two conditions in that case. So that's abstract. It's easiest just to understand examples, so look at examples. So let's look at number one. So first criterion is that every line in this vertical sequence has to be a woof. And if you know Gensler's system, his syllogistic language, you'll see that these are all woofs. The next requirement is that every letter has to occur exactly twice. And we do. We have two A's, we have two B's, and we have two C's. So we're good to go. Moreover, they do form a chain. So the first two lines have a B in common, the second two lines have a C in common, and the third and the first lines have a letter in common. And so you can see that when the letters form a chain, that you can kind of trace all the way through the argument in a circle. So that ensures the proper connections between the lines for the STAR test to work. All right, so this is going to be a syllogism. Satisfies all the criteria. Now, I do want to go ahead and mention a caution that telling whether or not it is a syllogism does not tell you whether it's a valid syllogism. So I said, yes, this is a syllogism. That does not mean yet that it's valid or not. The STAR test will have to tell us that. That's a separate issue. So let's look at number two. Well, it's a vertical sequence. Every line is a woof, according to Gensler's rules for the language. E occurs twice, but here's a problem. G only occurs once. And notice that Y occurs 3 times. So the letters don't occur exactly twice. So no, it's not a syllogism. All right, so let's look at number 3. Let's see. We have every letter occurs twice, exactly. 2 P's, 2 M's, 2 R's, 2 Q's, 2 S's. It looks like they even form a chain. So we got a letter in common with the first 2 P's. The next 2 have M in common. The next 2 have R in common. The last 2 have Q in common. And the first and the last lines have S in common. So it looks like you can trace a continuous circle through all of these. Okay, and so the letters form a chain. So it satisfies almost all of the rules. You might be tricked by this one because notice that this third line, or fourth line, let me say, it's the fourth line, is not a woof. It's not a well-formed formula because it starts with a capital letter. And if you know the syllogistic language, you know that no woof starts with a capital letter. Capital letters refer to categories, and categories have to be quantified. You have to say how much of the category we're talking about. All, some, or none. So capital letters have to have one of those words in front of it. We can't start the sentence with just a capital letter. So this is not going to count as a syllogism for a different reason. All right, and then finally, number 4. Let's see. It is a woof. Every capital letter or every letter occurs exactly twice. And by default, the letters form a chain because there's only one line. You can think of it as the letters forming a really short chain. Okay? We don't have to trace it through multiple lines. So this actually satisfies all the rules for syllogism, and yes, it does count. Okay? So now that you have that under your belt, we're going to try to look at a different concept, the concept of a letter being distributed. Now, this is a concept that doesn't have any clear intuitive meaning. Don't worry about that. It's a technical meaning, and it actually goes all the way back to Aristotle, who was developing syllogistic logic for the first time in ancient Greek history. And so this concept comes from Aristotle. He developed a system that determines whether any syllogism is valid or invalid. And this is something that he came up with. So here is Gensler's version of it, his modern update to Aristotle. A letter that's in a woof or a syllogism is going to be called a distributed letter when it either occurs immediately after the word all, or anywhere after no or not. So it only has to satisfy one of those. It has to be a letter that's right after the word all or anywhere after no or not. And as a convention, we're going to underline the distributed letters. It's going to be the way that we're going to recognize each other's markings. The underlining is going to mean that. So let's test this out. Let's try it out. So all A is B. Well, anywhere after all. So that's distributed. The A is distributed. But we don't have any no's or nots in there, so that's all we got. It's just the A in that one. Let's look at number 2. Anywhere after no. So both letters are distributed there. Anywhere after no or not. So they're all distributed in number 2. Number 3, anywhere after no or not. So those are distributed. And then number 4, let's see, so immediately after all. All right, so those are the letters that are distributed. Now the star test for syllogistic validity. Now that we have the prerequisites, we know what it counts as a syllogism, and we know what a distributed letter is, we can understand the star test. So first of all, we have to remember that the star test only applies to syllogisms. So that's why you have to be able to recognize whether any of those arguments are syllogisms or not first. That will always be the first thing you do. See if it's a syllogism. If not, you can stop right there and just say the star test doesn't apply. But if it's a syllogism, then the star test is going to work. It's going to tell you whether it's valid or not. So, step one. You're going to underline the distributed letters, just like we've been doing. Step two, you're going to use that underlining to help you know what to star. All right? So you're going to star the underlined premise letters. If it's in a premise and it's underlined, you're going to star it. But this is where sometimes people get stumped doing this for the first time, where mistakes happen. You star the conclusion letters that are not underlined. So you do the opposite for conclusions. For premise letters, you star the underlined, the distributed letters, in other words. But for the conclusion letters, you star the ones that are not underlined, the ones that are not distributed. And then you just count the stars. So here's the rule. Once you've starred everything properly, you can just read off of it whether or not the syllogism is valid or not. So it's going to be a valid syllogism if every capital letter is starred exactly once. Okay, you've got to have one star per capital letter. If it's a small letter, it doesn't matter how many stars. But if it's a capital letter, it's going to be starred exactly once. Moreover, there's got to be exactly one star on the right-hand side of the argument, the right side. Otherwise, it's going to be invalid. All right, so that's the rule. So let's actually go back here to my question about whether they're distributed. Let's now ask, are they starred? Which letters are starred? Well, you star the ones in the premises that are distributed, that are underlined, and the ones in the conclusion that are not. Okay, so that's your starring. And then, let's see, number two. You star the ones in the premises that are underlined or distributed. And the ones in the conclusion that are not underlined, not distributed. But those are underlined, so we don't star them in number two. Number three. In the premise, we star the ones that are distributed. In the conclusion, we star the ones that are not distributed, not underlined. And then in four, we star the ones in the premises that are distributed or are underlined, but there are no premises. This is a premiseless syllogism. So in the conclusion, we star the ones that are not underlined or distributed. Okay? So that's how the starring works. So now let's apply the star test. I'm actually going to shift back over now to this slide. Okay. So this is the same slide I just had up, except I already have them. It's neater. I have them starred and underlined in a cleaner way. You can see them more easily. So let's just see if it passes the star test. So what we got to do is make sure, so looking at number one, every capital letter is starred exactly once. And yes, we have A starred once, C is starred once, and B is starred once. Okay? And then moreover, we have exactly one star on the right-hand side. So it passes the star test, and therefore it's valid. Number two. Well, let's see. C is starred exactly once. B is starred exactly once. But A is starred twice. It's going to fail the star test for that reason. But notice it also fails the star test for another reason. It's got two stars on the right. So this fails the STAR test twice. So is it valid or invalid? Invalid. Number 3. So let's see. It's got 1 star exactly on the right, so that's good. That's satisfied. Is every capital letter starred exactly once? Well, there are no capital letters, so we don't have to worry about that. Notice that the small letter is starred twice, B, that is, and A is not starred at all. But because they're small letters, it doesn't matter. It only matters that every capital letter is starred exactly once. Okay, so this actually passes the STAR test. It's valid. And then finally, number 4, every capital letter starred exactly once? Yes. And 1 star exactly on the right? Yes. Therefore passes the STAR test and therefore is valid. All right. So hopefully that helps you with determining syllogistic validity, applying the STAR test. The good news is that once you're able to understand this test, you can determine whether any syllogism is valid or invalid. It doesn't matter how complicated it is. It could be 20 lines long. It's just a mechanical procedure. Going through and underlining after you check to make sure it's syllogism first. Underlining, starring, counting up your stars. And then you can just read off of it your answer, valid or invalid. So yay! That's actually very useful for you. So I recommend practicing as much as possible until you get the hang of it, until you feel like you're not making any more mistakes. We will go on to consider one more test, the Venn diagram test, although it only applies to specific kinds of syllogisms. The STAR test applies to all of them, so you'll still need the STAR test, even when we learn the other test. Okay? All right, so we'll stop there. Thanks for listening.